Okay, so here's example 8. Calculate the maximum speed at which a car can travel on a frictionless banked track of radius 75 meters. So here's your track. This is 25 degrees. Okay, here's your car, so to speak. This is the reaction force acting that way. Okay, and we know there's two components of that. There's the vertical component and there is the horizontal component that is like that. Okay, so ignore that. So that's your vertical component there. Okay, and that's your horizontal component, and these are 90 degrees to each other. As I said, ignore that there. Okay, this is theta. That's r. This is equal to mg, and mg is like that, and this here is equal to mv squared on r. So we're asked to work out the maximum speed at which the car can travel. So the way to do this is to think about the fact that tan theta is equal to opposite over adjacent. Okay, so it's equal to mv squared on r over mg. So tan theta equals mv squared on r divided by mg. So that is equal to mv squared on r mg, and the m's cancelled out, so it's equal to v squared over rg. So v squared is going to be equal to tan theta multiplied by rg. So that means tan 25 multiplied by r, which is your radius, that's 75 meters, given that there. And we know that g is obviously, 9.81. Okay, it does say it's 9.8 here, but I'm going to use 9.81. So if we put that into the calculator, we're going to get tan 25 times 75 times 9.81. Whoops, should have put the bracket on there. And that's going to give me 343.09, and therefore v is going to be the square root of that. Okay, so if we square root that, we're going to get 18.52 meters per second. Okay, so that's the first bit done. So that was part 1. Now part 2, calculate the angle of banking needed on a test track of radius 200 meters. So we've got r is 200 meters. We've got the car speed is 54.54 meters per second. And we know that g is equal to 9.81. So we're going to use the same equation again. Tan theta equals v squared over rg, as we've shown up here. Okay, and it's asking us to work out the angle. So tan theta is equal to 54.54 squared over 9.81 times 200. Okay, so if we put that into the calculator, 54.54 squared divided by 9.81 times 200, and that's going to give me 1.52. So theta is going to be tan to the minus 1 of 1.52. Okay, and that's going to give me 56.66 degrees. Okay, so that's that one.